Don't round off. You cannot have too many numbers, but you can't have too few. So don't round off to the sig figs on this. Because if you round off too much, you end up messing up your answer and not getting the right answer. All right, so the first thing we're going to do is we're going to look at the sample problem on page, where is it? It's on page 7. We're looking at the sample problem at the middle of page 7. Determine the empirical formula of a compound that is composed of 36.5% Na, 25.4% S, and 38.1% oxygen. Now, when you have a percentage, remember that that's based on 100. Suppose I had 100 grams of this stuff. If I had 100 grams of this stuff, how many grams of sodium would be in it? 36.5. So because of that, we can just go ahead and change this percent sign in our mind or on our piece of paper to grams. It is a percentage, so I can say if I had 100 kilograms of this stuff, how many kilograms of sodium would be in it? 36.5 kilograms. If I had 100 boxcars full of this stuff, how many boxcars of sodium would I have? 36.5. Because it's based on 100, I can think about it in any unit I want to, but most of the time percentages are by mass, especially in this unit. Percent by mass. So we change it to grams because that's what we use. Now the first step says find the number of moles. Can you change grams to moles?
Yes.
I hope so.
Yep.
We've been doing this for a while, haven't we? Grams to moles. So 36.5 grams of sodium and 22.9 what? 22.99 grams sodium, 1 mole sodium. All right? We know how to do that, so I'm not going to spend a lot of time on it because we've had 2 tests on it already. You should know basically what I'm doing here. If you don't, then you'll have to ask. All right, so I do that math, which y'all will be doing that for me. Then I'm going to take 25.4 grams sulfur, and I'm going to say 32.07 grams sulfur, 1 mole sulfur. And I'm going to take 38.1 grams of oxygen, 16.00 grams oxygen, 1 mole oxygen. All right, so do the calculation for me. 1.58. What's the next number? 7, and then what? 6. Okay, so that's probably plenty of numbers. You know, if you go a little past where it would normally stop with significant figures, then you'll probably be okay. But if it's a 5, you might not want to stop when it's a 5. You might want to go on to a number that's more like a 7 or a 8 or a 3 and 2. But as long as you've got several numbers here, it's not going to mess you up.
Oh, so you
What
want to do a
messes
lot.
you up?
You want to do a lot in the...
Right.
Oh,
What messes you up is to round off to 2 numbers instead of at least 3 or 4. So you cannot have too many numbers, but you can have too few. Okay? All right, when we do this one, what is it when we calculate this one, somebody? 20. So I can stop with 2, can't I? Because I got a 0 coming up next, and 3 would be the right number. And I got a 0 coming up next, so that's probably okay. Then the next one.
2.38.
Let's say it again. 2.38. 1. I I can probably stop with the 1. That's one more than I really need, significant figure-wise. So I'm probably okay with that. Now, the next step says set up a ratio of the elements. Well, set up the ratio of the elements. A ratio looks like this. Na colon S colon O. The colon shows that I'm setting up a ratio. Sodium is to sulfur as is to oxygen. Now, you put these in order that they're given in the problem. Most of our problems, they're given to you in the correct order. So don't mix them up. If sodium is the first thing you're told in the problem, then put sodium first. Okay? So keep them in order. That way you don't have as much trouble figuring out if you got the answer close or not. Alright, now I'm going to substitute in the number of moles that I just calculated over there. So sodium I calculate as 1.5876, sulfur 0.792, and oxygen was 2.381. All right, you see what I did? I substituted in the moles that I've already calculated. Then I'm going to divide by the smallest number of moles. This is sometimes a problem. Some people are a little bit math challenged, and they can't figure out what's the smallest. Because sometimes you have really weird numbers. Maybe you have 0.00862, and you have 0.00095, and people will look at that and say, well, the 9's bigger. But you have to go decimal place by decimal place when you compare. So you compare the first decimal place, they're both zeros. You compare the second decimal place, they're both zeros. And then you compare the 8 to the 0 smaller. So don't get that part wrong. All the numbers should be 1 or bigger. None should be less than 1. All right? So, let me just tired of this one. Now it says to divide by the smallest number. So I'm going to divide by 0.792, 0.792, and 0.792. Those are I'm dividing each one of them. Well, I already know that one right there is 1. I know from the experience of the day that this is 2. It's very, very close to 2. It's not going to be exactly 2, but it's going to be 2.002 something, something, something. So if it's 2.00 and then other numbers, I of course can round it off to 2. If it's 1.99 something, 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 I can round it off to 2. But if my decimal is not really close to a whole number, don't round it off to 2 or whatever number, because you're going to have to look for common fractions, which I'll go over in a minute. So it has to round off very close to exactly that whole number. All right? So, I didn't get my same color I want. When I divide this, I get 3. It's very close to 3. Maybe it's not exactly 3, but it's very close. Now I'm going to look for common fractions. Since all of these were whole numbers, there are no common fractions, so I skip number 6. No common fractions, skip number 6. Well, that rounded off to what? A whole number, didn't it? That rounded off to a whole number. When I have 2.33, I can't round that off to a whole number. I have to keep it. Then I would look for a common fraction. Okay? As long as it's a 0 right there, then I can forget about the common fraction. So it's 10 to the 0, when I round it off to the 10. All right, so now I'm going to substitute in the number for subscript. So NA, the subscript is going to be 2. S, the subscript is going to be 1. We don't write a 1 down, so I just put 1. And oxygen is going to be 3. Now, if it's not a carbon compound, you can usually check it. Is that a compound that you might be able to name yourself? Yes. Is it balanced? Yes. Sulfate's a -2, sodium's a +1, and there are 2 of them. So does that equal 0? Yes. So when I finish, if I have a compound that I could name and it's balanced, I'm pretty sure I got it right. Okay? All right.